Hi, Edwin. What time are we starting?
Hello.
Ladies and gentlemen, please make sure that you are in the right breakout room. This is the Engineering and Technology breakout room. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Welcome to the 2022 Virtual 3MT National Level Competition. So now, before we begin, I have a few friendly housekeeping announcements to make. During the whole program, I will need cooperation. And for participants joining via Zoom, please be reminded to disable the microphone throughout the event. So should there be any questions, please do write it down in the chat box. Thank you for your kind attention. Admin.
Beli keluar ke? Ke Grab?
Siapa kita? Grab je lah.
Malas ni. Tanya lah. Tu mi.
Welcome back. So before we begin, let me introduce you to the moderator judges for the Engineering and Technology category. The moderator for this room is Professor Dr. Hanafi Hussein, the Dean of Faculty of Creative Arts, University Malaya. Thank you, Prof. Hanafi. Moving on to the Chief Judge of this category, introducing Dr. Bhuvendra Rundrusamy from School of Engineering and Physical Sciences from Heriot-Watt University. The second judge would be Mr. Wan Kamarudin Wan Ibrahim from TV Al Hijrah. And the third judge is Professor Surveyor Dr. Wan Maimun Wan Abdullah from Ahmad Zaki Resources Pahad. Welcome to all judges, and thank you for being here with us today. Now, before we begin, I would like to brief everyone of the competition rules. The competition rules are: presentations are limited to 3 minutes and competitors exceeding 3 minutes are disqualified. Presentations are considered to have commenced when a presenter starts their presentation through speech timing, does not include the 3MT title slide, and commences from when the competitor starts speaking, and not from the start of the video. A single static slide is permitted in the presentation. This can be visible continuously or cut to for a maximum of 1 minute. The 3-minute audio must be continuous and no sound edits or breaks. No additional props, for example, costumes, musical instruments, laboratory equipment, and animated backgrounds are permitted within the recording. Presentations are to be spoken in words. For example, no poems, raps, or songs. No additional electronic media, for example, sound and video files, are permitted within the video recording. And the decision of the adjudicating panel is final. Please note, competitors are not judged on video or recording quality or editing capabilities. Judging will focus on the presentation ability to communicate research to a non-specialist audience and the 3MT PowerPoint slide. Now, the judging criteria will be based on the comprehension and content. The presentation provided a clear background and significance to the research question, which is clearly described in the research strategy or design and the results, findings of the research. Presentation clearly described the conclusions, outcomes, and impact of the research. In terms of engagement and communication, the oration was delivered clearly and the language was appropriate for a non-specialist audience. The PowerPoint slide was as well defined and enhanced the presentation. The presenter conveyed enthusiasm for the research and they captured and maintained the audience's attention. Let's go to the best part. The prizes for the first place is 1,500 ringgit for 3 categories. For second place, we'll take home 1,000 ringgit Malaysia for 3 categories. And for the third place, you will take home 700 ringgit for 3 categories. Now, the bonus were special prize for representatives from Malaysia. You will receive €750 for 2 participants. Moving on, we have come to the most exciting part of the event. Our first participant for the engineering and technology category. Introducing our first participant, University Malaya will be represented by Ana Akilah binti Baharudin, will be presenting on high performance breath acetone sensor for diabetes diagnosis.
Poking myself every single day using a device. So stressful. Oh, and I forgot to bring the other device for blood tests. Why can't they make it into one device only? I wish that there was a better way to do glucose tests for diabetes. This is the reality that is faced by most diabetic people. Sometimes they have to do the test multiple times a day. Because it is inconvenient and painful, they sometimes skip glucose tests. But diabetes can lead to other complications like heart disease and so much more. So people with diabetes should not skip testing their blood glucose level. Not only is it bad for their health, but the Malaysian government spends 3 billion ringgit a year just to treat complications related to diabetes. So how do we solve this problem? What if I tell you that there is a better way to do glucose tests? People with diabetes have higher than average acetone content in their breath. What is acetone? Acetone is chemical waste excreted from the liver into the bloodstream and then into our breathing system. This is where my research comes in handy. I have developed a high-performance device that can detect acetone content in a person's breath, which indicates whether that person is in a diabetic state or not. Let me tell you how it works. When you breathe into the sensor, its electrical conductivity changes in response to acetone. So instead of using 2 devices required for the painful blood test method, people now can detect diabetes by using only 1 device. And it is as simple as taking a breath. This cost-effective sensor is also wireless, so people can use it anywhere, at any time. How convenient. If people find it easy to use the device, they are less likely to skip glucose tests. This improved technology will also encourage people to receive early treatment and avoid other health complications related to diabetes. By using this high-performance breath acetone sensor, government expenditure in the health sector is also expected to reduce immensely. At the end of the day, everyone is happy, case closed.
That was Aina from University Malaya. Moving on to our second presenter this morning is from University Science Malaysia, USM, Denny Hartanto Jarum, with his presentation entitled How AI Can Protect Us Against the Silent Killer, PM 2.5.
Do you know that 7 million people die each year due to air pollution? That's more than the whole population of Singapore. Now, the main pollutants that's causing this is called PM 2.5, which stands for particulate matter 2.5. And as the name suggests, it represents any particles in the air that has a size of less than 2.5 microns. Now, how small is 2.5 microns? Well, you could pluck a strand of your hair, and PM 2.5 is 50 times smaller than the hair that you're holding right now. It is incredibly small and virtually invisible to human eyes. It is so small, it can enter your lungs, into your bloodstream, and start damaging your organs. Now, in some cases, it could even lead to death. According to the World Health Organization, 95% of the people in the world still breathe in high level of PM 2.5. Now, why is that? Well, it turns out that a lot of these people are simply unaware of the PM 2.5 level in their area, and I don't blame them. A single monitoring station costs at least $250,000 to construct. And as you can imagine, not a lot of people have access to such system. Now, our goal is to bring back this access to all of these people. But how are we going to do that if it costs so much? Well, that is the breakthrough of our research. Instead of using expensive sensor, we use machine learning model to predict PM 2.5 using simple weather informations like temperature and wind speed. Now, this is how it works. Think about the first time when you learned how to ride a bike. Initially, you fell over and over again, but then as you practice, you got better and better, and eventually you knew how to ride a bike. The same goes for machine learning model. Initially, it will generate a lot of bad predictions, but then as it learns from its past mistakes, it gets better and better, and eventually you get a really good model. Now, matter of fact, with our most recent deep learning model, we were able to achieve up to 80% accuracy. And on top of that, we were able to integrate the model with a cloud server, which means that every single person in the world that has access to this simple weather information could now get the latest PM 2.5 forecast for free. Now, we're not talking about one or two places. We're talking about 200,000 different locations worldwide. Now, with this, we'll be able to alert and warn people of dangerous PM 2.5 level, and hopefully reduce the number of casualties it may cause. Now, this is a small leap in a very big problem. But if that means that we could save even just one single life, it is all that matters.
Well, Danny, that makes me feel like I was listening to BuzzFeed for a while there. Now, moving on to our next presenter with her presentation entitled Safe Hydrogen, Driving the Future of Renewable Fuel. Please welcome Dayang Siti Nurzailin binti Abang Syamsuddin, representing Universiti Kebangsaan Malaysia, UKM.
Have you ever thought that one day we're going to stop using petrol? Do you know that in 2050, fossil fuel, which produces our petrol, is expected to be extinct? So what do we do then? The answer is to produce renewable fuel, such as hydrogen fuel, to fill up our cars, use it as a cooking gas, generate electricity, just like our current fuel. In fact, we already have our first hydrogen plant in Sarawak. You might ask, why hydrogen fuel? Well, because hydrogen can be produced from renewable sources, such as water, which is plentiful, making it a reliable alternative to fossil fuel. Sounds promising, doesn't it? However, hydrogen is extremely flammable. But worry not, because my research is going to solve this problem and make hydrogen safe for public use. How? My research predicts the hydrogen explosions, the causes and its impact, so that proper safety design can be developed for us to use it safely. Previously, most explosion study through experiment cannot be conducted in a large scale, and it's dangerous. That's why my research uses simulation method rather than experiment so that I can conduct unlimited studies. And of course, I don't want to explode anything and risk the safety of myself and others. So how does my simulation model works? The concept is just like when we play firecrackers. Let me share you my childhood memories where I played Meriam Buluh with my siblings. What happened was we light up a whole bunch of firecrackers in the bamboo and then we ran away. But we were hit and injured badly after the explosions. We were surprised because we don't see any fire or anything hitting us. So what actually hit us that causes injuries? It is actually a blast wave that was produced during the explosions that couldn't be seen with our own bare eyes. But using my simulation model, this wave can now be seen virtually as shown in the slide. On the left is the actual explosions where you cannot see the blast wave, while on the right is my simulation model where the blast wave can now be seen. The bigger the wave, the bigger the impact. Now that we can see the wave, we're able to develop proper, safe operating procedure of hydrogen. In other words, if I had my simulation model when I played Meriam Buluh, I would have known where to run and not get injured. Ultimately, this research is important to ensure a safe environment for people to use hydrogen as a fuel. So in future, we don't have to worry about running out of fuel because hydrogen fuel can be safe to use with proper operating procedure. The world is shifting from fossil fuel to renewable fuels, and this is where my contribution on safe hydrogen application is crucial.
Wow, that was another level of insight on how Meriam Buluh works. Things are getting very interesting. Our next presentation will be entitled My Manganese UFO, presented by Villain Anak Lelaki Rahman from University Putra Malaysia, UPM.
I was a child, I've had an interest in two things, building blocks and UFOs. Today, as a researcher in the field of reticular chemistry, I happily get to deal with both, just not in the way you might expect. You know how children play with Lego blocks, joining and stacking them? Sometimes without realizing it, they create beautiful structures from random arrangements. This is what happens in reticular chemistry. We take metal salts, connect them with organic molecules called linkers, and put them in a repetitive arrangement to obtain new frameworks or new materials that improve our lives in various ways. For my doctoral research, I chose to study how manganese may combine with nitrogen because there has been little research done on this rare combination. Similar to baking a cake, I set out to produce a new framework by mixing manganese chloride with nitrogen linkers in the presence of the solvent and popping the mixture in an oven for a few days at an optimal temperature. Now, manganese is a metal that can be bonded with 5 or 6 other molecules to form an extended framework. So I was hoping to obtain a new framework with the manganese unit connected to 5 or 6 molecules of nitrogen. But what a surprise popped out of the oven! I found that not only did manganese connect with nitrogen, it also unexpectedly connected with chloride from the manganese salt. You see, chloride is an inorganic molecule and not expected to be a linker. But now it had actually become part of the new manganese framework. Instead of manganese plus 5 nitrogen, I'd obtained manganese plus 3 nitrogen and 2 chloride. This was my UFO. unexpected framework outcome. It turned out to be a beautiful synthesis with a unique repetitive arrangement never before seen. And I have named it MnVLN. My research unexpectedly showed that chloride can function as a linker to possibly produce even more UFOs. But what's so special about this current UFO? Well, manganese is widely used in energy storage devices like batteries. So I arranged my new framework into a battery-like device to test its capacity for energy storage. And initial results showed improved capacity. This is encouraging because larger energy storage means longer lasting batteries. I have to do further analysis on the shelf life of my UFO, but with more work, it might eventually let us charge our batteries just once a week. And one day, it might even provide power for a UFO of the flying kind. Thank you.
That was Villain from UPM. So moving on to our fifth presenter for this morning, which is the final presenter for our first slot. Just to let you know, we have 3 slots for today. So our fifth presenter this morning is Ratosivan Gopal with his presentation entitled Cardiac Plaster for Cardiac Bleeding Application from University Technology Malaysia, UTM.
What would you do when you cut your finger or fell and injured your skin? After cleaning the dirt and blood, what do you do? Surely, most of us will put a plaster to prevent further bleeding and let the wound heal. But I'm sure that most of us are unaware that this bleeding also possibly occurs in our heart, and similar plaster concept can be applied on sealing the bleeding. Yes, I'm a biomedical engineer currently developing a thin polymer membrane as a plaster to seal and stop the bleeding from heart. Now, you may wonder why a heart needs a plaster. How can it bleed when it's already covered with blood? Allow me to clear your doubts. We are familiar with patients undergoing open heart surgery due to severe heart problems. This means that to operate, their chest is cut open for a direct contact on the heart to treat the disease. Now, bear with me. It already sounds terrifying, but what makes it worse is the complications followed by the surgery. Would you believe me if I say that there are some cases where the patients are rushed back to the operation theatre again after the surgery due to the bleeding complications from the heart? The bleeding happens, well, not because of the heartbreak, obviously, but because of the leaking of the blood from the sachet region during the closure of the cut after the surgery. It's shocking. And as a Malaysian, I don't think we need this kind of buy one, free one offer in such a life-threatening situation. But unfortunately, it happens unexpectedly. So to address this problem, this membrane will be attached on the heart surface as a sealant right after the surgery, as shown here. But we need an agent to stop the bleeding. And for that comes our rescuer called Factor 7. Now be clear, it's called Factor 7, not James Bond 007. But dare I say, both of them have something in common, is that Agent 007 saved our life from terrorism, and this Factor 7 saved our life from bleeding. It's not something new. Factor 7 naturally present in our body and is responsible to stop bleeding. So by attaching this membrane on the heart surface, This membrane seals the sutured region while our very own Agent 007 takes in charge whenever the bleeding happens in our heart. And it's completely safe for our body. So in short, the heart bleeding can be a traumatic experience, but it can be prevented at an early stage by applying this membrane, and the patient can return to their normal life in no time. So why worry much when our very own James Bond is there to save your heart from bleeding? Thank you.
Welcome back. So now we will take a 10 minutes break for the judges to deliberate on the participants' presentations. Please remain in the breakout room for all the participants and refrain from entering the judges' breakout room to avoid being kicked out of the event. So to all the judges, we would like to invite you to proceed to the judges' breakout room. Thank you. We will be back in 10 minutes.
The roots of our business are more than 175 years old. When our flagship journal Nature was first published 150 years ago, only a third of the world's population were able to read. Today, the majority can. Nearly 2/3 of the world's population lived in extreme poverty. Now, most are poverty-free. And average life expectancy was just 38, where today that number is over 70. Yet despite this progress, inequalities still remain, and the world faces new and significant societal challenges, such as climate change, universal access to healthcare, and quality education. Progress will only be possible because of the vital role that scientists, researchers, academics, and educators play. And in a world where truths are verified by social media clicks and fake news is easily spread, they are more reliant than ever on being able to share their insight and trust their sources. This is where we play such a pivotal role. As custodians of the academic record, we aim to safeguard the independence and veracity of research, helping researchers to trust and build upon the discoveries that have gone before. Each experiment, every finding, taking its place in the network of discovery and enabling researchers to stand on the shoulders of giants. Let's see how that works in practice. This is Nature's publication record, 150 years of interconnected research, represented by the majority of Nature's papers. A snapshot of the ever-growing web of collaboration and discovery that is science. Let's take Watson and Crick's seminal paper on the structure of DNA as an example. Here it is. Below it is every paper that it referenced. Not just Nature papers, every paper. Then every paper that those papers referenced, and so on. Above it are all the papers that built their work based on Watson and Crick's discovery. Every paper has its own story, its own unique network, and each of those networks connects to others to form a whole. Every paper in every field, playing their part in the global process of research and discovery. And with these discoveries come advances, not only in science, but in medicine and healthcare, in the arts and social sciences, and progress across all professional fields. At Springer Nature, we aim to ensure that fundamental knowledge can be found, verified, widely understood by those that need it, and then used. In the laboratory, in the field, in the classroom, in the hospital, and even in the driving school. We take our global responsibility to our communities, employees and society extremely seriously, with trusted and respected brands, a footprint in more than 50 countries, and nearly 10,000 employees around the world, from editors and science writers to analysts, developers, and production specialists. We work in local offices, close to our communities, where our knowledge and experience can make a difference. One Springer Nature, working together and using our scale and influence for the greater good. Setting ourselves bold ambitions as a business to be more diverse, to do all we can to protect our planet, to bring together researchers, policymakers, and practitioners to accelerate progress towards the UN's Sustainable Development Goals, and continue to lead the way in opening up research, ensuring that the world makes as much progress in the next 150 years as it did in the last, improving and enriching our lives, and helping to protect our planet for future generations. Springer Nature, opening doors to discovery.
The people who built Springer Nature have been opening doors to discovery since the beginnings of modern science. The research we publish has provided a trusted source of knowledge to make progress towards a better tomorrow. We build on this legacy with the United Nations Sustainable Development Goals, a blueprint to achieve a better and more sustainable future for all.
We work to support researchers across the globe as they tackle urgent societal needs, connecting them with practitioners in policy and business who desperately need those insights to improve the world.
We work to amplify the discoveries in our multidisciplinary books, journals, and cutting-edge science journalism, opening up and disseminating data and insights for those who need it most.
We work to innovate by investing in new services and technologies, such as machine learning to identify SDG-relevant content, providing insights and tools to empower our customers and stakeholders to deliver.
We take responsibility for the environmental and societal impacts of our own business operations, cutting our carbon footprint, working towards greater inclusion and diversity, and forging strong links with the communities we serve.
With 2030 fast approaching, we work to deliver real progress in addressing the most urgent societal needs, because we are a company of researchers,
engineers,
writers,
communicators,
and leaders
committed to advancing discovery for the benefit of future generations.
Hi, I'm Karen Low, the founder of Malaysia Women Marathon. I am 51 this year. I have run 63 marathons. I have done the ultra marathons like 100 kilometers. In 2017, I was diagnosed with cancer.
I'm Nantini, I'm 33 years old and I'm a cervical cancer survivor. I'm a mother for 2 boys and I'm also a baker, an honor for Shani Baking.
You know, when you're told that you have cancer, you don't really understand what it means. It's just a shock for you because for me, I was very healthy, I was very active, I was very fit. And again, as I said, being fit does not mean you're healthy. The first time I had to go to see an oncologist was even worse because the oncologist's office room was very far into the ward and I had to walk quite a distance and that journey was really, really lonely. Wouldn't want people to go through that. Yes.
I was having a very bad bleeding, okay, and it was a non-stop bleeding and hair losses. And also I was getting thinner and thinner. From 65 kg, I dropped until 45 kg. When I received the call from Miss Gayatri, I was on the way to a temple. We are going to the temple, nothing will going to happen, you will be safe. Then only I started to cry, and I was like, I'm going to die. As I remembered, when I was young, there's no medication for cancer. So what I thought is I will die.
The first time I went to get my chemo was something that only a person who's gone through chemotherapy will realize because the first time is always something that is very special to you. It's just like, you know, your first marathon run or your first baby or your graduation. So it was an experience that I had to face. Perhaps God had a message for me to bring myself to know how it is like so that I could relate to people and maybe share with them more experiences on how it's like.
Professor Wu, she told me that I need to take about 25 to 27 fractions of radiation, 5 cycles of chemotherapy, and 4 times of brachytherapy. My husband paid everything because I'm not under insurance lah. So what happens, each and every time we went, we will spend about 200 ringgit for our transportation from here, from my house, over to PPUM. We will move out from here early in the morning, 5 o'clock. We will stay there for we will stay there about 18 hours or 16 hours, we will be there. We will be only coming back home about 5 p.m. or 6 p.m.
It took her a while to convince me that chemotherapy was the only treatment for me. I was very adamant not to go through chemo, having heard all sorts of stories about chemotherapy and a bad effect on a person, the healthy cells. So when you ask me what would I have done different in terms of chemo, I will not tell people avoid that. I would tell people go ahead, do the chemo. It's nothing that you should be afraid of. A lot of people say, oh, chemo, tak payah buat lah. We were so ignorant about it. Yeah, we didn't read enough. We didn't know how it would affect the body. We just knew from other people say, oh, the chemo is so strong that it's going to kill all your good cells in the body also.
Women need to get the information from the right places and from the right people. Sometimes a misconception or perception of what the treatment may involve may actually cause them a lot of fear and anxiety. Therefore, as a doctor, it is important to walk the journey with them and to make sure they have all the information and support that they need.
At one point, my boss called me and said, you can't work anymore. Please quit your job. I'm the one and only person who was working because my husband is handicapped. So I need something to release my stress. That was the time where I start to bake, and we open up a company which is called as Shani Baking, and I got lots of orders lah from my previous colleagues, my friends, my family.
So I'm the type to find running a meditative mode. I'm like, when I run, then I'm thinking of solutions. My husband said, are you sure you want to run? Oh, I have to run. If I don't run, then I'm not going to feel good. So I actually literally do 2 to 3 km. And I went back to work also. I just didn't want to feel as if it was going to bring me down. But I wasn't going to let it defeat me.
So what happens is when I go to my interviews, they will be giving a form and they say that, do you have any sick or not? There's one column where they will ask, do you have any sick? So I can't lie to them. So I need to be genuine. So I'll just mention that I'm a survivor cancer. I actually passed in all the exams and everything. The only word is destroy my whole, what we call, my career. So that was the time where I hate myself. Why am I like this? Why I got the sick? Why not other people never get the sick? But my husband is there. He's there. I can't, I will never ever, I'll never ever say thank you. I cannot say any word lah. I can't describe anything about him. He's the person who was there for me. He's a handicap, but then he done more than a normal person.
The people don't understand what cancer means and the different degrees of cancer. And the first time my children heard that I had cancer, they cried because they thought they were going to lose me. And the first thing that we need to be doing is to be brave, actually, to be brave for the people around you. It's not something that it's easy to do, but being brave shows that they know you are ready to fight the disease, and they know that we will be doing anything that will include them to help you. So it is very important that we get people to be by our side emotionally, so that we can get this battle against the cancer done. When we say we, is this people. Yeah, I'm very grateful for friends. I'm very grateful for a few people like Professor Wu and Dr. Melda Belchin, who
Moving on to our second part this morning. Thank you for tuning in and for staying with us for the second part. So moving on, my name is Valerie, your MC for this morning. So we would like to welcome our first participant for the second slot of Engineering and Technology category. Please welcome Fung Pei Yi for her presentation entitled The Greatest Welder from University Malaysia Perlis UNIMAP.
Nowadays, plastic product was normally produced by molding, but the structure of advanced application are too complex to be molded as a single piece. Therefore, assembling of a subcomponent into the final product is important. Welding is now the most efficient way of plastic joining. What is the first thing that springs to mind when you hear the phrase welding? Is it the dangerous dazzling fire spark deal with metal pieces? Yes, but did you know welding is not just for metal? It may also be applied on plastic material in a safer way. In general, variety of plastic welding had been commercialized. However, these welding methods have a common challenge, which is geometry restriction. And the main problem is their machine is expensive. So today, I'm here to introduce you to an economic welding method called microwave welding, which is unprecedented. Actually, microwave welding is a welding method that works with microwave heating, like how we prepare our food in microwave oven. For your understanding, the heating mechanism of our food in microwave oven is due to the presence of water molecule. The water molecule in the food will absorb the microwave and lose part of it as heat, causing the food to heat up. It's the same for microwave welding, a susceptible material like water molecule that can efficiently absorb the microwave is needed to heat and melt the plastic. Let me tell you how microwave welding works in just 3 simple steps. Susceptor preparations. Apply the susceptor on one of the plastic surface, couple it with another plastic surface, send it into the microwave oven, and voila, the welded joint is done. This welding method holds great promises. Now, let me tell you why. First, the susceptor not only functions to melt the plastic, but also a nanofiller in the formation of nanocomposite welded joint. From the experimental result, microwave welded joint is 275% stronger than the neat plastic product itself, as a man can hang it in the air by relying these small microwave welded hooks. It's cool, right? Second, the processing time was significantly reduced from hours to seconds. Third, it can be applied on components with any geometry. Lastly, and the most importantly, it is a safe and affordable method that only have 3 simple steps and everyone can perform without any training and skill. With this rapid microwave welding, a strong welded joint can be produced by anyone. Now, everyone can be the greatest welder.
Now we have come to our second presentation for this morning from University Islam Antarabangsa Malaysia, UIA, by Muhammad Muiz bin Muhammad Nawawi with his presentation entitled ECG Biometric, T-shirts and Verification of Human Identity.
Would it be nice if you could withdraw your money from an ATM machine merely by standing there without the need for a password, or to fuel gas without using your credit card, and the amount is deducted merely by you yourself near the machines? Let me introduce you to your future identity, where a t-shirt worn by you is all that needed to verify your identities, not your heartbeat as a biometric data. 20 years before, we will not even be able to imagine that heartbeat, our heart could represent our identity, who we are and who we claim to be. Kind of give me the songs, my heart will go on, all new meanings. This heartbeat or ECG signal was introduced as a potential biometric signatures to overcome issue of currently available biometric signatures, which could be falsified by sticky fingerprint, static iris, face image, voice miming, and fake signatures. Why ECG biometrics? My daughter once asked me, what is biometric, Abba? A biometric is a security process that is based on a biological signatures, such as ECG, to verify if people are who they say they are. Like, is Abba really Abba? A lot of previous research on ECG biometric have concentrated on using electrode connected to the body, whereas a little has been done about non-contact ECG biometric, such as in a wearable smart tester. And usually, when hearing about ECG, a lot of people tend to imagine lying down on a clinical bed, static movement, and a lot of annoying sticker on their body. However, in my study, getting this ECG signal without having all that annoying thing, it's just like you're wearing your daily t-shirts and doing whatever you want to do without realizing your biosignal data is collected and your identity is verified. Kind of like an Iron Man, except instead of Mark 42, it's now your shirts. How do I do this? By wearing the t-shirts, the data is transferred to the phones, which then compute this data to the analyzer program, and the result will then pop up on the screen. Voila, identity verified. Every individual is unique. With ECG biometric, we are now can be cashless, cardless, and still have the world at the tip of our finger, or rather, at the tips of our t-shirts. Thank you.
Moving on to our next presenter from University Malaysia Sabah, UMS, Awang Nasrizal bin Awang Ali, with his presentation, When Resistance is Futile, Strengthening Stormwater Management Using Agro Wastes.
Have you ever wondered what is in our stormwater system? Some might not want to care about this, but for people who are in the line of civil engineering like me, this is where we could find 1001 environmental problems with unfortunately limited solutions. Typically, drainage is used to remove the excess stormwater. This stormwater is usually conveyed without treatment, carrying all the potential pollutants, including dust, nutrients, and even metals, before it goes into a water body or river and eventually ends up in the sea. Using a turfing method and ponding systems, of course, has reduced floods and other environmental problems. However, due to rapid urbanization, the areas required to build such a pond have become one of the constraints. The main idea of my study is to introduce a filter into the stormwater system. This will reduce the burden of existing treatment while increasing the aesthetic value of stormwater and improving the quality of stormwater at the point source of the pollution. Another exciting part of my study is the filter media itself. Typically, conventional sand is used in various filter applications. However, what if we use waste to treat waste, materializing the concept of transforming waste into wealth? The agriculture sector in Malaysia has shown considerable growth, which contributes about 8% to the national GDP. Furthermore, this subsequently leads to the production of more agro waste. Previous research has demonstrated the potential of utilizing this agro waste in water and wastewater treatment. The benefits of using agro waste, such as oil palm kernel shells and coconut shells, are that they are readily available in abundance, can be obtained at a very low cost and have the favored properties to perform efficiently as a filter media. Last but not least, this agro-based filter media would be able to treat the stormwater when optimized based on the filter configuration, loading rate, and pollutant concentration, achieving the aim of cost efficiency, which is also in line with the national agenda of promoting sustainable development, particularly in water resources management. My name is Awang Nasrizal from the Faculty of Engineering UMS. Thank you for listening.
That was from University Malaysia Sabah. Moving on to our fourth presenter this morning, Rose Manisah binti Muhammad, with her presentation entitled Clean Water for All. Please welcome from University Pendidikan Sultan Idris, UPSI.
We cannot survive without water. Water is needed for drinking, sanitation, to produce food, and for maintaining our ecosystem. More than 785 million people do not have access to basic water. What more, having access to safe water to drink. Evidently, according to the water.org, over 1 million people die each year from diseases related to contaminated water. Without us realizing, this precious resource is slowly being taken away by the rapid growth of development. And look around, such as textile industry is one of the main culprits that has led towards water pollution. This contaminated water is being discharged directly to the river, causing damage to the aquatic life as well as to human beings. Filters in the market has some limitation as they cannot be used multiple times, costly and time-consuming. So, how do we make it cost-effective and yet environmentally friendly? Through my PhD research, I have discovered a better solution, which is cost-effective and long-lasting. This is not just any filter, but it is a membrane with nanomaterial. With this nanomaterial included, the membrane can be reused over and over again. Isn't this cost-effective and practical? The use of this invention will only take a few seconds to filtrate the contaminated water to the clean one. And yet, the impact is big. Imagine if we do it in a large scale, where we use this membrane to treat all the wastewater around the world. We are giving a better hope and future for millions of people. Water is life. Let's save the world together.
Welcome back. So before we proceed, we would like to apologize for some glitches earlier. However, rest assured that the judges are viewing the actual video. So now some may view the video and the audio may not sync. So this is all subject to your own respective internet connection. All right, so our next presenter, which is our final presenter for our second round this morning, which is from University Technical Malaysia Melaka, UTEM. Dahlia binti Johari with her presentation, Heat Transfer Correlation for Thermoacoustic Energy System.
Before I start, let me ask you a question. All of us has refrigerator in our house, right? It is one of the most important necessities in our home. But then, we know that our refrigeration system contains chlorofluorocarbon that can deplete our ozone layer. Less ozone layer protection will over time damage crops and leads to higher skin cancer and contributes to the greenhouse effect. So, how to reduce this CFC usage without compromising the refrigerator production? This is where the thermoacoustic system came into places. Imagine, by only using some or precisely the right adjustable sound frequency, we can produce a cooling system. Amazing, right? As you can see from the left-hand side of the slide, there are scientific evidence where Ben and Jerry cooler produced 115 watt of cooling power in 2004, and Tokai University has produced with minimum temperature of -50 degrees Celsius in 2017. This is quite amazing for the thermoacoustic system itself. But then, there are many researchers have done the application part and finding the performance of the thermoacoustic system. However, the fundamental understanding of this thermoacoustic flow condition is scarce due to the complexity of the flow itself. This is where we take the responsibility to study the flow inside the system. From the right-hand side of the slide, you can see that our test rig is quite bigger compared to the Hasegawa rig. This is because we want to see the flow inside the system. The middle figure is some of the results from the simulation of what happened to the flow and the heat transfer inside the system. So, with this kind of result, we can develop a new correlation that is specific for thermoacoustic system that can help the future researcher in order to enhance the performance of thermoacoustic study. With that, I thank you.
We will take another 10-minute breaks for the judges to deliberate on the participants' presentation for this round. Another gentle reminder to the audience, please refrain from entering the judges' breakout room or else you will be kicked out from the event. So to all judges, kindly proceed to the judges' breakout room. Thank you. We'll be back in 10 minutes.
The roots of our business are more than 175 years old. When our flagship journal Nature was first published 150 years ago, only a third of the world's population were able to read. Today, the majority can. Nearly 2/3 of the world's population lived in extreme poverty. Now, most are poverty-free. And average life expectancy was just 38, where today that number is over 70. Yet despite this progress, inequalities still remain, and the world faces new and significant societal challenges, such as climate change, universal access to healthcare, and quality education. Progress will only be possible because of the vital role that scientists, researchers, academics, and educators play. And in a world where truths are verified by social media clicks and fake news is easily spread, they are more reliant than ever on being able to share their insight and trust their sources. This is where we play such a pivotal role. As custodians of the academic record, we aim to safeguard the independence and veracity of research, helping researchers to trust and build upon the discoveries that have gone before. Each experiment, every finding, taking its place in the network of discovery and enabling researchers to stand on the shoulders of giants. Let's see how that works in practice. This is Nature's publication record, 150 years of interconnected research, represented by the majority of Nature's papers. A snapshot of the ever-growing web of collaboration and discovery that is science. Let's take Watson and Crick's seminal paper on the structure of DNA as an example. Here it is. Below it is every paper that it referenced. Not just Nature papers, every paper. Then every paper that those papers referenced, and so on. Above it are all the papers that built their work based on Watson and Crick's discovery. Every paper has its own story, its own unique network, and each of those networks connects to others to form a whole. Every paper in every field, playing their part in the global process of research and discovery. And with these discoveries come advances, not only in science, but in medicine and healthcare, in the arts and social sciences, and progress across all professional fields. At Springer Nature, we aim to ensure that fundamental knowledge can be found, verified, widely understood by those that need it, and then used. In the laboratory, in the field, in the classroom, in the hospital, and even in the driving school. We take our global responsibility to our communities, employees, and society extremely seriously, with trusted and respected brands, a footprint in more than 50 countries, and nearly 10,000 employees around the world, from editors and science writers to analysts, developers, and production specialists. We work in local offices, close to our communities, where our knowledge and experience can make a difference. One Springer Nature, working together and using our scale and influence for the greater good. Setting ourselves bold ambitions as a business to be more diverse, to do all we can to protect our planet, to bring together researchers, policymakers, and practitioners to accelerate progress towards the UN's Sustainable Development Goals, and continue to lead the way in opening up research, ensuring that the world makes as much progress in the next 150 years as it did in the last, improving and enriching our lives and helping to protect our planet for future generations. Springer Nature, opening doors to discovery.
The people who built Springer Nature have been opening doors to discovery since the beginnings of modern science. The research we publish has provided a trusted source of knowledge to make progress towards a better tomorrow. We build on this legacy with the United Nations Sustainable Development Goals, a blueprint to achieve a better and more sustainable future for all.
We work to support researchers across the globe as they tackle urgent societal needs, connecting them with practitioners in policy and business who desperately need those insights to improve the world.
We work to amplify the discoveries in our multidisciplinary books, journals, and cutting-edge science journalism, opening up and disseminating data and insights for those who need it most.
We work to innovate by investing in new services and technologies, such as machine learning to identify SDG-relevant content, providing insights and tools to empower our customers and stakeholders to deliver.
We take responsibility for the environmental and societal impacts of our own business operations, cutting our carbon footprint, working towards greater inclusion and diversity, and forging strong links with the communities we serve.
With 2030 fast approaching, we work to deliver real progress in addressing the most urgent societal needs because we are a company of researchers,
engineers,
writers,
communicators,
and leaders
committed to advancing discovery for the benefit of future generations.
Hi, I'm Karen Low, the founder of Malaysia Women Marathon. I am 51 this year. I have run 63 marathons. I have done the ultra marathons like 100 kilometers. In 2017, I was diagnosed with cancer.
I'm Nantini, I'm 33 years old and I'm a cervical cancer survivor. I'm a mother for 2 boys and I'm also a baker, an owner for Shani Baking.
You know, when you're told that you have cancer, you don't really understand what it means. It's just a shock for you because for me, I was very healthy, I was very active, I was very fit. And again, as I said, being fit does not mean you're healthy. The first time I had to go to see an oncologist was even worse because the oncologist's office room was very far into the ward and I had to walk quite a distance, and that journey was really, really lonely. wouldn't want people to go through that. Yes.
I was having a very bad
Welcome back to the 3 minutes thesis national level competition. Now moving on to our last 4 participants for this morning. The next participant will be Ashwindran Naidu anak lelaki Sandera Sagran from University Malaysia Pahang UMP with his presentation entitled Bio-Inspired Wind Turbine for Low Wind Speed Region.
Ladies and gentlemen, we engineers have the power and ability to influence the world for a better future. Remember, with great power comes great responsibility. The sole responsibility of an engineer is to provide a simple yet innovative solution to a problem. The problem that human race is facing now is the side effect of excessive usage of non-renewable energy resources, namely fossil fuel, which resulted in the rise of greenhouse gases index and global warming. Guys, by the way, global warming is real, it's not a joke. Putting aside the scandalous and profitable relationship between politicians and fossil fuel, I'm here today to advocate the usage of renewable energy, or to be specific, wind energy. The concept of extracting energy from the flowing wind using a wind turbine is pretty simple and straightforward. However, it becomes complicated and frightening for an engineer when it comes to the design principle of constructing a wind turbine. This fundamentally means that the capability of a wind turbine in harvesting energy is subjected to its design configuration and local wind speed. Speaking about wind speed, it has been told that the wind energy harvesting is not feasible in Malaysia due to its geographical location and wind characteristic. Sorry, today I'm not going to concur to such prejudice statement. Please allow me to revolutionize the way of your thinking, so please bear with me. The reason behind such statement is because Malaysia utilized wind turbine that is specifically developed for high wind speed class region, namely Denmark, China, and India. This is evident enough that conventional or traditional wind turbine design is not suitable relative to Malaysia's geographical properties and wind pattern. Therefore, fundamental design reconfiguration and modification is required on conventional wind turbine. Bioadaptation comes to the rescue. The aim of my research is to construct a wind turbine inspired by the elements of nature. Prior engaging into bioadaptation technique, design attributes of 7 years wind turbine is analyzed in terms of its geometrical properties and aerodynamic behavior. Interestingly, it has been found that the performance of 7 years wind turbine is governed by its blade shape and auxiliary aerodynamic design feature. Therefore, bioadaptation technique is utilized to resolve those issues. Hence, the blade shape of the proposed wind turbine design is reconfigured as a result of the mathematical formulation extracted from the geometrical analysis conducted on traditional 7 years wind turbine blade shape. Result shows that the rotational properties of a proposed wind turbine improved by 15.5% compared to traditional 7 years wind turbine. In the near future, with this research methodology, we are able to reconfigure any existing wind turbine in order to harvest clean energy in Malaysia effectively. Ladies and gentlemen, let us lay a clean and sustainable future for our future generation. Thank you.
We have come to the middle part of this round. So please welcome our next presenter, Ooi Wan En, with her presentation entitled From Ash to Building from University Malaysia Perlis UNIMEP.
Ladies and gentlemen, this is the Earth portrayed in the movie Wall-E, produced by Pixar Animation Studio back in 2008. In merely 700 years, the Earth will look like this, overrun with rubbish and no longer a home for human beings. Today, because of human activities, a lot of waste materials will landfill, polluting our environment. The movie is turning into reality. But we cannot stop development. Global urbanization, economic development increase the demand for new building and infrastructure, which relies heavily on cement. Cement is the key ingredient of concrete, the second most used resource on Earth. It is produced through crushing, grinding, and heating of limestone. Accounts for as much as 8% of global carbon dioxide emission, and we are well aware of the consequences of rising carbon footprint. Here is where I step in. To my knowledge, the byproducts from electric power plant, water treatment plant, or steel mill can be converted into 1 part geopolymer, which is essentially a green building material that can replace cement. 1 part refers to a dry mix of all the ingredients used to make geopolymer. Geo stands for earth, poly is many, and mer is parts. The preparation of this material produced 84% less carbon dioxide than the production of cement. So how is this material made? In the movie, the cleaning robot Wall-E collects rubbish and making them into blocks. Well, in my context, I'm the present-day Wall-E. I collect fly ash from coal-fired electric power plant, add some chemicals, mix it with water to produce blocks, which is the 1 part geopolymer. Note that this material can be applied by simply adding water, which is similar to the ordinary cement. So far, our 1 part geopolymer is 3 to 4 times stronger than cement in general, meaning that now we can use less amount of material to produce a similar product. In the end, that's all my research is about, is to offer a solution for reducing carbon footprint, is to offer a solution for waste management, and finally, to offer a solution for human beings to continue living on the earth.
Our fourth presenter is Rafiqah binti Salimon from University of Technology Petronas, UTP, with her presentation entitled Factors Affecting the Soil-Rock Mixture, SRM Behavior.
I was born in 1993, and that is one of the happiest years for my family, but not to some others. In December 1993, 48 people perished in seconds after a Highland Tower in Kuala Lumpur collapsed due to landslide. And this tragedy is just one of the 100 landslide episodes that had occurred in Malaysia that had caused loss of life and damages cost up to billions. In 2007, Go and Time reported that 60% of this landslide occurred due to design error and 20% occurred due to design and construction error. Now, you might wonder where all this error come from. Well, this error occurs when we poorly understand and wrongly characterize the earth material we are dealing with, which made up of soil and rock. And in nature, soil and rock can exist naturally as a mixture, or what we call as soil-rock mixture, or SRM. SRM are loose material composed of fine-grained soil and certain percentage of rock blocks with various shape, size, and strength. Thus, SRM are extremely inhomogeneous and complex, but they are often treated as homogeneous to avoid tedious analysis, and this could lead to design error. So how we can properly characterize them? This is where my research comes in. Previous study had shown that the shear strength of SRM are largely controlled by the rock block proportions and the granular distribution. However, there are significant factors such as moisture content, soil type, and rock block shape that are limitedly studied. My work is to determine the influence of this factor towards the SRM mechanical properties, and we come up with two significant conclusions. The first one, we determine that the moisture content, the soil type, and the rock block shape actually influence the interlocking force between the composed material in SRM. By playing around these parameters, we have further understood how they influence the shear strength of SRM and then how to control it. Secondly, we know that the rock block shape have minor influence as compared to the rock block strength. For instance, a weaker angular rock block will have a lower shear strength as compared to rounded, strong rock block. Generally, in industry, we know that the experts, the engineers, and the geologists are excellent in treating soil, rock as rock. But I believe that this gray zone between soil and rock border, which we call a soil-rock mixture, is something that we need to work on further together. If we can anticipate all these factors and recognize how they affect on the mechanical properties of SRM, we can create a safer structure. We can create a safer structure, make a better design, and hopefully preventing landslide from occurring.
Ladies and gentlemen, we have come to the end of our session for this breakout room. So now the moderator will proceed to the main judge breakout room together with the judges for some final decisions. Audience may now return to the main hall for the most exciting part, that is the finalist announcement for this afternoon. Remember not to enter the judges breakout room to avoid being kicked out from the event. So to all judges, we would like to invite you to kindly proceed to the main judge breakout room. We apologize for the glitches. University Malacca
has been to a fun fair at one point in their lives. I believe we've all seen the jet ride, the one with multiple jets hooked on.
We apologize for the glitches. All right. So we would like to welcome our final participant for this category from University Technical Malaysia Melaka UTM, Khairun Najmi bin Kamaluddin, with his presentation entitled Pneumatic Actuator Controllers, Adaptive and Robust Tracking Algorithm.
Everybody has been to a fun fair at one point in their lives. I believe we've all seen the jet ride, the one with multiple jets hooked onto a big center pole, the one that can elevate and descend as you wish to the input of your stick inside the jet, just as you would on a real plane. Kind of. Well, I hope you get the idea. In general, most of us will understand that those jets are hooked onto a very strong electrical robotic arm. The actuator will react to the input of the stick that you're holding, either to elevate or descend. Imagine you're an engineer and you think you want to try something different with that actuator. What is something that is cheaper and simpler in the market? Pneumatic actuator. Pneumatic actuator is also quite common. It uses compressed air as compared to electrical energy on those robotic arms. Well, to start off, there's a fundamental issue. If you replace those robotic arms with the high pneumatic actuator, the rider can only go to the maximum height or to the minimum point. No control in between. With innovations, behold, servo pneumatic actuator. Its integrated positioning sensor allows this to move in between, adds more flexibility. Now, in my research, we designed the brain of the servo pneumatic actuator. In our field, is called a controller. So basically, we are a control system designer and engineer. My research with adaptation of a few elements will make this brain as precise and robust as possible. What does robust and precise mean? Let's say we want to elevate the jet to 1 meter. We are able to move it to 1 meter within 1 millimeter precision, 2 meters to 1 millimeter precision. Very precise. Robustness. We have various riders on those weight with various weights, 100 kilograms, 50 kilograms, children, 5 kilograms. Even with those weights, the controller is able to move the actuator to that precision without any compromise. Now, in our field, we adapt the so-called nonlinear proportional integral derivative controller, which is quite common as well, but with a hybrid with a fuzzy controller. This automatically makes it an adaptive controller. Where can we move on from this contribution? Well, we can adapt the algorithm to other types of pneumatic actuators. We have the rotary actuators, air vents, air motors, air muscles, and so on. Not limited to pneumatics, you can apply it to hydraulics, mechanical actuators, other electrical actuators, chemical actuators. The application of this algorithm is unlimited. Thank you.
Welcome back. So we have come to the end for this category. So we would like to invite the judges to the judge breakout room, and we would like to invite all the audience to proceed to the main hall for the final announcement of the finalists for this afternoon. So we would like to thank you for joining us today. Signing off, Valerie. Thank you.
The roots of our business are more than 175 years old. When our flagship journal Nature was first published 150 years ago, only 1/3 of the world's population were able to read. Today, the majority can. Nearly 2/3 of the world's population lived in extreme poverty. Now most are poverty-free. And average life expectancy was just 38, where today that number is over 70. Yet despite this progress, inequalities still remain, and the world faces new and significant societal challenges, such as climate change, universal access to healthcare, and quality education. Progress will only be possible because of the vital role that scientists, researchers, academics, and educators play. And in a world where truths are verified by social media clicks and fake news is easily spread, they are more reliant than ever on being able to share their insight and trust their sources. This is where we play such a pivotal role. As custodians of the academic record, we aim to safeguard the independence and veracity of research, helping researchers to trust and build upon the discoveries that have gone before. Each experiment, every finding, taking its place in the network of discovery and enabling researchers to stand on the shoulders of giants. Let's see how that works in practice. This is Nature's publication record, 150 years of interconnected research, represented by the majority of Nature's papers. A snapshot of the ever-growing web of collaboration and discovery that is science. Let's take Watson and Crick's seminal paper on the structure of DNA as an example. Here it is. Below it is every paper that it referenced. Not just Nature papers, every paper. Then every paper that those papers referenced, and so on. Above it are all the papers that built their work based on Watson and Crick's discovery. Every paper has its own story, its own unique network, and each of those networks connects to others to form a whole. Every paper in every field, playing their part in the global process of research and discovery. And with these discoveries come advances, not only in science, but in medicine and healthcare, in the arts and social sciences, and progress across all professional fields. At Springer Nature, we aim to ensure that fundamental knowledge can be found, verified, widely understood by those that need it, and then used. In the laboratory, in the field, in the classroom, in the hospital, and even in the driving school. We take our global responsibility to our communities, employees, and society extremely seriously, with trusted and respected brands, a footprint in more than 50 countries, and nearly 10,000 employees around the world, from editors and science writers to analysts, developers, and production specialists. We work in local offices, close to our communities, where our knowledge and experience can make a difference. One Springer Nature, working together and using our scale and influence for the greater good. Setting ourselves bold ambitions as a business to be more diverse, to do all we can to protect our planet, to bring together researchers, policymakers, and practitioners to accelerate progress towards the UN's Sustainable Development Goals, and continue to lead the way in opening up research, ensuring that the world makes as much progress in the next 150 years as it did in the last, improving and enriching our lives, and helping to protect our planet for future generations. Springer Nature, opening doors to discovery.